This is a molecule. It makes a fragments showing 87, 111, and then 126. And then it's asking what are the structures of the fragments. Well, molecular ion takes a 144, right? If we're going to do the fair amount of substitutions and subtractions to figure out what goes out. So for instance, since it's an alcohol, we can imagine alcohol makes a dehydration pretty quickly. So that makes it M minus 18 pit. So if you make the 144 minus 18, that accounts 126, which we should explain what it is. So that signal should be the dehydration. That is something that we can gather. But after that, still that makes it 111 and then 87. So how are we going to explain that? So this is what we talked about. The allylic positions, we can have a carbocation, then it makes a resonance stabilized carbocation. So that fragmentation can happen somewhat, abundantly. So you may be able to see, even though it's a method radically kick it out, but this is a resonance stabilized, allylic carbocation. So that is probably could happen. And then that is basically you can start from 126 and minus 15 because the method radical goes out. That makes a 111. I mean, even before the structures, 111, 126 is about 15 differences. So you maybe start guessing that, where you can kick out the method groups out. And then I hope that you can find the right positions, not that side, but this side next to the other ones. But what about 87? 87 is a kind of significant fragmentation happen. We like to break down almost equal parts. So what makes an 87? So for that, you still have an idea that what is the major fragmentation. For the alcohol, alpha cleavages. We talked about this. Alpha cleavages makes a resonance stabilized, really stable carbocation. So that is one of the major fragments for the alcohol. When you break it, you can break either this side or that side. But this molecule, it doesn't really matter because it's symmetrical. So when it breaks down, you got the carbocation and then OH there, that's resonance stabilized. If you add the numbers of the carbons and hydrogen oxygens, you're going to find out that is at 87.